Hi everyone, welcome to today's live session on the Advanced Python Programming course by SimpliCode. In this session, we will learn all the important advanced topics that you need to know to become a Python developer. Our experienced instructor with ample industry knowledge will take you through this course. So before we get started, make sure you subscribe to the SimpliCode channel to learn new technologies. So we will begin by understanding what are iterators, modules and packages in Python. Then we will learn about generators and look at list comprehensions in Python. Moving further, we will see regular expressions and serialization in Python. Next, we will get an idea about partial functions, closures and decorators. Finally, we will end this session by learning map, filter and reduce functions in Python. So let's get started.
Hello everyone and welcome to another video on Python programming. In this video, we will be covering the topic of iterators. Now, an iterator in Python is an object that contains a countable number of values, or it's a larger object that contains a countable number of sub-objects. An iterator is an object that can be iterated upon, and what that means is we can traverse from each value and we can manipulate or perform certain functions or operations and tasks using each of the sub-objects or values within this larger collection called iterator. Now, when we're looking at it technically, an iterator is an object which implements the iterator protocol in Python, which consists of the methods iter and the method next. So to begin with, let's look at a simple iterator. We're going to see the example of a list where we're going to traverse through the objects of a list using the for loop. So we have objects 1, 2, 3, 4, and I'm going to print each of these values one by one, as you can see here. Similarly, we can also do the same thing for another iterable known as the string, where we can go character by character, again using the for loop, as you can see here. Another example of an iterable in Python is the dictionary. So let's say I have a dictionary where I have two values, two key value pairs, key x, which contains the value 1, and key y, which corresponds to the value 2. Now, when I'm going to do a for loop through this, by default, I will be traversing through the keys x and y, as you can see over here. And of course, the other types of iterables in Python are like sets and tuples as well. All right. Now let's look at what this iterating protocol is in Python. So first of all, we take an iterable. It's an object that contains, it's a collection of objects that contain sub-objects. And when we use the iter function, it creates an iterator out of it. So we can, one by one, we can traverse through each of the objects and we can manipulate each of the objects that is contained in this. And anytime we want to move to the next object, we use the next function. And when we have finally completed all of the, or we've manipulated or traversed through each of the sub-objects, we encounter the stop iteration exception, which tells us, okay, there are no more objects to be manipulated or iterated upon. So as an example, I will create a list where I will store the values, some simple values, integers 1, 2, 3, 4, 1, 3, 4, 5. Okay. I'm going to create an iterator out of this where I will use the iter function. And I'm going to say this is, let's say this is called my iter. Okay. And I'm going to use the iter function as I had mentioned, and I'm going to pass my list in this. Now, if you see what is my iter, it should be a list iterator at a particular memory location. Now let's use the next function to keep going through whatever is there in this. So of course, the first object should be 1, as you can see. Now when I look at the next, it should be 3, then I should get 4, and now I should get 5 as I use the next successively. Now since I've reached the last of my objects in this collection, now the next time I use this next function, I should get a stop iteration exception that is raised, as you can see here. So this is the basic iteration protocol in Python. Now you might have already gone through the for loop video, and in that I have spoken in quite a bit of detail as to how a for loop performs this iterator protocol and how it creates an iterable object out of, say, a list or a tuple, and how it internally performs the next function, and it breaks out of the for loop once it encounters the stop iteration exception. So for loops are like, they're very, very similar to your standard iterator, and they use pretty much the same protocol for its functioning. Now, let's do a basic comparison of what is a basic comparison between a generator and an iterator in Python. So in generator, we use a function. We define it using the def keyword, and we define it under one function to create a generator. Whereas in the case of iterators, we use two separate functions, the iter function and the next function. The generator makes use of the yield keyword, whereas the Python iterator does not. In generators, we save the states of the local variables each time we use the yield keyword, and we pause the loop temporarily. Whereas in iterators, we do not make use of any local variables. All we need is an iterable like a list to iterate upon. We may use any number of yield statements in generators, and we do not use yield statements in iterators. Generators are not memory efficient, whereas iterators are very memory efficient. So this is like basic comparison between generators and iterators. In this video, we will be covering the topic of modules in Python. Now, a module in Python, to put it simply, is basically a Python file that has functions and classes written into it and is saved with the .py extension to specify that it is indeed a Python file. A Python program can use one or more modules, and modules can have one or more functions. They basically help us organize our code, and instead of having one long Python file, we can have several files or several modules. Now, modular programming is the process of breaking a large event or task into smaller and more manageable subtasks, and we call these subtasks basically modules. Now, individual modules can be grouped together like building blocks to create a larger application. There are several advantages to modularizing code in a large application, and we will be going through them right now. So first of all, there is simplicity because instead of focusing on a big problem or big task, we can break down the problem into smaller portions or modules. Now, maintainability of code is much better through modules because they are designed to create these sort of boundaries or clear demarcations between different problem domains. There is reusability in the sense that once we create a module, we can use it in different parts of the code or even different applications itself. There is also scoping, and what this means is modules typically define a separate namespace, and this helps us avoid collisions between identifiers in different areas of a program. Functions, modules, and packages are basically all constructs in Python that promote code modularization. You might have already come across or gotten an intro into functions. In this video, we will be going through modules. And in another video, we will also cover the topic of packages. To import a module, we use the import keyword. And in this example, what I'm going to show you is a simple function or a simple operation of importing the OS module. This is short for operating system. And as the name suggests, we can perform system tasks through the functions and methods that are part of this OS module. So simply executing the statement will import this module onto our program for us to use. Now, if we wanted to see all the functions that are present in a module, what we have to do is use the dir function. So if we print the dir OS function, it will print us basically a directory of all the functions that are present in the OS module. As you can see here, all of these are basically names to different functions that are part of the OS module. Finally, moving on, another function commonly used with modules is the getCwd function. And what this does is it will give us the current working directory that we are working upon right now. So if I execute this, it will tell me what is the directory that I am currently working upon right now. As you can see, C notebook dir/temp. If we wanted to see all the files in a particular directory, what we can do is use the listdir function followed by giving a path. By default, if we do not enter a path inside the parenthesis, it will basically give us all the files in the current working directory, which in our case is temp. So if I were to execute this, it basically gives me a list of all the files that are presently there in the directory that I am currently working upon. Now, a basic step is creating a Python module. The simplest way to create a Python module is basically creating a Python script with whatever functions and tasks that we want and methods that we want inside whatever module, and saving it with a .py extension. So in my example, what I'm going to do is I have already created a script in Notepad, and I've stored it with a .py extension that contains these four functions: add, subtract, product, and division. I've basically used this code and I've stored it in a .py script, and I'm going to be using this as my as a test module for this particular example. Now, how do we import a module? Now, once that I have created a script, in my example, it will be called mycalc.py, and we've stored it in our directory. To import the module, all we have to do is use the import statement. So if I have to import mycalc, all I have to do is say import my underscore calc. And now my calc has been imported. So we can use the import statement, or if we want to import something particular from my calc, we can do from my calc import. Now we can, whatever, like for example, if we wanted the add function, we can basically just say only add, or if we wanted add and subtract, we can say add and subtract, for example. So this is basically by using from, we can say that we want something from something, but only parts of it. We don't want everything. We can also use from my calc import, and we can say asterisk to basically say import everything that exists in my calc right now. So this is another way of importing something from a module. Now to access contents in a module, we have to use the dot operator, and I will show you how right now. So what I'm going to do is, in my example, I'm going to import my calc as calc. So now since this is the original folder or the original module, but I'm going to give it a shorthand name so that I can easily use it in my code and I don't have to type out my underscore calc every time. So now I'm going to import this as calc. So anytime I have to refer to a particular method or function inside this script or this module, I will just use this placeholder, this variable name. So now I have two variables, a and b, and I'm storing 20 and 30 in them. So my first what I'm going to do is basically 4 operations. I'm going to print the addition of a and b, and then the subtraction, multiplication, and the division of these two numbers. And each time to do this operation, I am going to use the add function that is present in the mycalc module. So to do that, I have already imported mycalc as calc. All I'm going to do now is invoke these functions using the dot operator that we are already familiar with. So I'm going to say calc.add, and then I'm going to pass these two arguments or these two variables to say that I want to add these two. And similarly, I'm going to do it for subtraction, multiplication, and division. As you can see, these are the results of my tasks. Now, if I had to do a directory operation on the module calc, it will basically give me a bunch of inbuilt or dunder methods that are already a part of any Python script by default, such as built-ins. So if I execute this just to show you what happens when I use the dir function, it will basically give me all the functions that are part of this Python script. So these double underscores that you see are basically denoting magic methods or dunder methods, and these are like inbuilt methods as a part of the script. And if you see here, add, division, prod, and sub, these are the methods that we have defined earlier on in our script ourselves. Now to go slightly deeper or in more detail into what happens when we do a module search, let's actually look at what happens. So what happens is when, for example, we execute the statement import mycalc as calc, as we did over here. So the steps that actually take place are the interpreter executes the above statement and it searches for this Python script in a list of directories assembled from these following sources that you see here. So it takes the directory from which the input script was run, or the current directory, if the interpreter is being run interactively, which is the case right now. Secondly, it will list all the directories contained in the Python path environment that you set up, that you can set up or you can change later on as well. And this format for Python path is OS dependent, of course, but it should mimic the path environment variable that we see in Windows systems. And then the other source or the other directories is basically an installation dependent list of categories configured at the time Python is installed. Now the resulting search path that is accessible in the Python variable system.path, this is basically obtained from a module named sys. So if I imported this sys and I did sys.path, now these are all the directories that we are going to look for when we want to search for any particular module. So if I'm doing import mycalc or import OS, it's not only going to look at the current directory that I am working on, it's also going to look at all of these directories that have been set up as you could say directories or paths in the system.path. In this video, we will be covering the topic of packages. Now, what if we developed a very large application in Python that contains many different modules, and we have so many different modules that have similar names and functionalities, and they're all kept in or dumped in the same location, that it becomes very difficult to track these modules? What if there was a way to organize and access these in a much simpler and more organized manner? Well, packages allow us to do just that. Packages are a hierarchical structuring of the module namespace using dot notation. And this is the same dot notation that we use when we want to access methods or functions that are part of other classes or modules. So let's look at certain examples to understand what we mean. So I have a directory called pkg. This can be basically treated as what we call a package. Now in our package, we have two modules, mod1.py and mod2.py. And what we're going to store in mod1 and mod2.py are the follows. So I'm going to define a function called foo, and I'm going to print this particular statement, mod1, and then I'm going to basically say foo. And then I'm going to say in class foo, I'm going to have an empty pass command. Similarly, I'm going to define a function called bar in mod2.py where I'm going to print this statement. So basically mod1.py has a simple function where I'm going to print this statement, and mod2.py has a simple function that I'm going to print this statement. And I'm going to store them in mod1 and mod2.py respectively. And these two modules I'm going to store in the directory pkg in my local folder. Now I've already done this, so we can already get to working with this. Now if I wanted to access these particular modules from the pkg folder, I can simply use the import command and use the dot notation. So I can say pkg.mod1. So this will import the mod1 module from pkg folder. Similarly, I can do the same thing for the mod2 module from the pkg folder in the same line. So now that it's been imported, just simply execute this, and this imports whatever we needed. Now, if we wanted to perform a function that was a part of mod1.py, we can just extend the dot notation and use the function as over here. As you can see, it performs this print command, whatever it was supposed to do. Similarly, I can invoke the function that was part of the mod2 module by extending the dot notation to it in the same way. Now, another way that I can invoke I can import a package is by directly importing the package itself by using import pkg and not accessing any of the specific modules within it. Now let's see what happens when we do this. So just for this example, what I'm going to do is I'm going to restart the kernel so that the pkg modules that were already imported get cleaned away. So we see what happens when we execute this on its own. Now if you see, I have imported this. Now let's see if I can access my mod1 and mod2. Now if you see here, it's throwing me an error. And this is because simply using the import command on a particular package only imports, you could say, the package namespace, but it does not actually import any of the modules and files that were part of this package. So if I wanted mod1 from this package, I would have to actually say import pkg.mod1 directly. And I cannot simply say import pkg, and Python will not import everything that is part of a package on its own. I have to specify it myself specifically. Now I'm going to create, and I'm going to show you another type of importing from a package using the star operator. So I have this package pkg once again. Now I'm going to store 4 different modules within this package: mod111.py, mod222.py, and I've already done this, so you don't need to bother about seeing me doing it right now, because I've already created these files. And what I've done is within mod111.py, I've written this statement and I've stored it in the Python script. Similarly, I've created another Python script called mod222.py, and I have basically written this in the code. And I've similarly done this for mod333.py, and I've done another for mod4.py. Now, once I have done this, I've stored these Python scripts into my package or pkg package. So now what I'm going to do is I'm going to execute this command. If you see this, from pkg.mod333 import star. So once I execute this, now I'm going to say print directory, and print directory basically will tell me all the functions that exist in my current directory. If you see here, there's this baz function that was a part of mod333 module. Now if I change this, and if I imported mod111, and if I did the same thing, you will see foo has now been added as a part of this directory. And these are all functions that were part of these different modules where I'm importing from. And that is what the star function does. What the star function will do is it will basically tell Python, okay, so the statement is saying from pkg.mod111. So it's saying that, okay, look into this directory or this package and find this module. And in this module, import everything that exists inside it up until this point. So this is another way of basically importing files or functions from a particular package and a particular specific module within that package. So yeah, this was a very brief video on packages in Python. The conclusion being that packages are basically an organized way of storing many different modules that we might have created in a very large application. And these modules can be accessed using the familiar dot notation that we have used in other examples, such as methods when we were working with classes and objects. In this video, we will be taking an introduction into the concept of generators. So Python provides a generator, which is like a function where we can create our own iterator. In a generator function, we use the yield statement instead of the return statement that we use for standard functions. So let's look at a simple generator first of all. So out here I have defined a generator called myGenerator, where I'm doing there are three functions or three tasks that I'm doing. First one is when I'm printing the first item and I'm yielding a value 10. Then I'm printing second item yielding 20. Then I'm printing last item yielding 30. So let's see how do we use this. Now, since we know myGenerator is the function, it uses the yield keyword. Every time we use the next keyword, we will keep getting what is next in this function. So let's store the generator in mygen. So now we have stored the iterator in this function variable called gen or gen. Now let's see, when we do next and we use gen, what happens? So the first task is performed, or the first iteration is performed, where we get this, the first yield command is done. Alright, let's see what happens when we do next again. Next gen. Now, as you can see, we get second item and we get 20. Let's do it for the next. Let's do it once more, since there is one more task. There's one more iterable inside. You can see this. Now, a valid question is, what will happen if we do next gen again, since there is nothing after this? Well, let's see what happens. We should get an error. As you can see, stop iteration error. This is another built-in exception that happens when we have reached the last object of an iterable. So we get a stop iteration error. So now a key difference between a generator and a function is that when we execute a function, the moment we hit the return statement in a function, or when we execute a function, like whatever variables that were stored inside are lost and they're destroyed unless they were defined as global. And the function is completely done executing and we leave the function completely. Whereas when it comes to a generator, when we hit the yield function, we don't actually completely leave this function. So the first time the yield is found, we get 10, but the generator remembers its position inside this function. So the next time we use the next, we actually move on to the next iterable, and then we move on to the next iterable. So you can think of a generator as it sort of has memory, if that makes sense. It's a way to create iterables in Python or create iterators in Python. So to understand what the difference between the yield command and the return command does, let's take the same function. Alright, and let's put a return over here after this particular, the second yield. Okay, let's do the same thing. We say gen is equal to my generator, and let's start doing next gen and seeing what's there. So the first yield will be standard, first item 10. The next one is going to say second item and then 20. But now if you notice, there was a return I put over here. So technically when I did the second next, it's not only yielded 20, but it's also executed this return function or this return statement. So let's see what happens if I do next again. As you see, I have gotten the stop iteration seemingly earlier than I did before. And that's because I have used the return function and return statement. And what that's done is that we've completely left this function, so as to speak, and there is nothing next, so as to speak. So we get the stop iteration, and that's the difference between yield and return. Now in the next example, I'm going to show you how we use a generator function in place of the for loop, or for a for loop. So let's take this, what I have over here, and I have defined a function called getSequence up to x, and what this will do is basically it will keep printing the printing numbers up until whatever we have entered in place of x over here. So if I said, say, sequence is equal to, let's copy this, all right, and say I want sequentially, I want every number up until 10. Well, not including 10, of course, because Python starts with 0, right? So let's do this, and now let's see. So the first number will yield 0. And now if I did this again, it should give me 1, 2, and I can keep going until I will stop at the value 9, as you can see here. So 8, 9. Now I should get the stop iteration error because that we have reached the end of our iteration. So this is a way of using generator functions for for loops. So another neat example where we're going to use a generator is in the case of Fibonacci numbers. So let's use it. Let's see how we can generate a Fibonacci series using generator. So I've defined a Fibonacci function called Fibonacci where I'm passing max. So max is basically the max value that I want, like up until where I want the sequence, right? So this is basically the code which will return me the subsequent values of my Fibonacci sequence. So let's pass this to fib and say I want all the Fibonacci numbers until 10. So I will pass 10 over here. Let's see what happens when we do next fib. Well, it should start with 0. Then when we do this again, we get 1. Then we do 0 plus 1. It should be 1. Next number should be 1 plus 1, which is 2. Then we should have 2 plus 1, 3. And then 3 plus 2, 5. Then 3 plus 5 should be 8. Now 8 plus 5 is 13. And since 13 is greater than what we passed for our max value here, now when we try this, we should get the stop iteration error, as you can see. In this video, we will be learning about the concept of list comprehension. Now, list comprehension it's a neat way of creating a new list based on values that are already there in an existing list. So you can think of it like creating a new list using a much shorter and cleaner syntax compared to what you might traditionally be thinking. So let's go through some examples, and through those examples, we will see how list comprehension makes creating these new lists much simpler and much easier for us. So in our first example, we will be creating a new list which will contain fruits that contain the letter A in their name. So we already have a list of fruits over here, as you can see. It has apple, it has banana, cherry, kiwi, and mango. Now we want to create a new list which has only the fruits that have the letter A inside them. So apple would be one of them, banana would be one of them, and mango would be one of them. So traditionally, if you look at this piece of code, this would do what we want to do, but this contains a few extra lines. But yeah, it does do what we want to do. Now what if there was a way of doing the same thing by just writing one simple line of code? And that exists, as you can see here. So I take the same list. Now this is where you need to follow. So now my new list is equal to, so I'm creating a list over here, as you can see. Now within this list you have this line. This is what we call a list comprehension. So as you can see, it says each fruit for each fruit in fruits if, now it's checking for the letter or the character A inside each fruit. And what this each fruit is, that we're checking each object in this list one by one. So first, in the first iteration, each fruit will contain the string apple. Then in the next iteration, it will contain banana. And in each iteration, we're going to check if it contains the character A. And if it does, then we store that each fruit in the new list, as you can see here. So if I execute this line, you see my result is the same. I have my whatever I wanted. And this was a much cleaner way of writing or creating this new list. Let's look at some other examples now. So my next example, what I'm going to do is I am going to iterate through a string. So I have a string. It can be anything. In this case, I am using a string called human. All right. So I have a string called human, right? Now I want to store each character of this string into a list that we call h_letters. So if I use the for loop, this is how we would do it. If I execute this, as you can see, the list contains h and then u, m, a, and then n. Now what if I wanted to do the same thing, but by using list comprehension? So what I would do is, let's create a list over here, h_letters, and so as we know, list comprehension will it's So you just basically need one line. In this case, it will just be like this. Now this is my string. Now let's see, when I check what's in H letters, let's see what is the output. So as you can see, I have the output as what I needed. So this is a much cleaner way. Let's go through some more examples now. Now we can do more list comprehensions. We can even use, so we've already seen one case where we checked for the character A. We've seen a case where we went through, where we did a sort of a loop through a string. We can also use list comprehensions in conditionals. So let's look at an example where we use the list comprehension with an if statement. So what if I wanted to store, say, the first 10 even numbers? So this would, this is an example that I'll be using. So in my list, I want to store the first 10 even numbers. So this would be a way to do it. So I have in range 20. So what this is going to do is X is going to take the value of 1, 2, 3, 4 and so on until 90. It'll actually take it from 0, 1, 2, 3, 4 until 19. So when we do range 20, we're creating an iterable where we're going to loop through or iterate through the values 0 to 19. So if I do this, and this, what this statement does is basically it checks if it's divisible by 2. So if this is equal to 0, that means we have an even number. And if this condition is met, that means we store the X into our number list. So let's see what happens when we execute this. This should contain 0, 2, 4, 6 until 18. So this is the first 10 even numbers, as you can see. So this is a neat way of using if statement. We can also use an if else statement. So what if I'm checking each. Okay, so I'm going to create another list, and in this list I'm going to basically see if each of my numbers are the even or odd, the first let's say 10 natural numbers. So let's write this statement down. So I want it to be even in case the I that I'm checking, I being every number between like say the first 10 natural numbers, as I said. Let's check if it is divisible by 2. Well, if it is divisible by 2, of course, it's going to be even, right? Else, we say that it is odd. And then we check for I in, say, the first, let's say the first 20. Okay. So now when we do this, and we check what's in the list. So as you can see, the list contains like even, odd. It's basically saying the number 0 is even, then the number 1 is odd, then number 2 is even, and so on and so forth. So this is an example where we used the list comprehension with if-else statements. So another neat thing that we can do with list comprehensions is that we can use it along with functions. So let's look at this function. In this example, we have a function called double x, where we define this double x, this double function to take an input, to take an argument x, and what we return is the square of the argument. So let's use this in our list comprehension. So what we do over here is that we're checking. What we're doing is for every x bit in range 10. So we're taking the value 0, 1, 2, 3 until 9, and we're passing it to this function double x, and we're going to get the square of them, and we're going to store that in a list, as you can see here. Let's call this list x. Let's just call this list let's call it y. So now let's see what's in y when we check. It should be 0, 1, 4, 9 and so on. So wait, let's check again. Does this square? No, this is actually 2 times. So let's make it square, as you can see. So you can see 0, 1, 4, 9 for the first 10 numbers, 10 natural numbers. Now what I've shown you is obviously list comprehension, but we can also do set and dictionary comprehensions. In fact, set comprehensions work exactly the same way as list comprehensions. The only difference is the set comprehensions will make sure that there are no duplicates inside the set. So you can't have like duplicate items, which you can in the case of list comprehensions. So let's just take a look at an example. So here in this example, what we're doing is we're going to check So we have this string that we're storing in the variable text, and the string is something like life finds a way. So whatever this is. Now what we're going to do is we're going to iterate through this string character by character, and we're going to check if we're going to check for vowels essentially. So we're going to see if the character A, E, I, O or U is present in the string, and if it is, we will pass it into our set. Now if you look, you will find there are multiple I's, right? And there are multiple A's as well. So if we did this through a list comprehension, each time that we find a vowel, it would be added to our list. But since this is a set and sets do not allow duplicates, so you will only have one copy or one particular object for each of the vowels. So of course now set comprehension is defined using curly braces, so let's keep that in mind. So now if I check what's in this, I will see A, E, I and U. Even though there are multiple A's or multiple E's or I's and U's, since this is a set, we don't have duplicate copies of any of these. So this was just a small example for showing you set comprehensions. Similarly, we can do the same thing, this comprehension for dictionaries, and we call it dictionary comprehensions. The only thing that we have to worry about when it comes to dictionary comprehensions is that we have to define a key when it comes to this. So let's look at an example. In this, what we're doing is, again, dictionary comprehensions are also defined using curly braces, just like sets, except in this case, we will define a key, and that separates it from a set comprehension. So in this case, what we're doing is that I'm checking, I'm going through a list of numbers from 0 to 9, right? This is what the range 10 function does. And what I'm going to do is, I'm going to create a key which is going to be like 0, 1, 2, 3, and the value of each key would be its square, as you can see here. I'm doing I times I, or just to make it a little more clearer, as you can see, I'm doing I square over here for every value from 0 to 9. So what I should get is like a dictionary where the first key is 0 and the value of that key should be 0 as well, because 0 square is 0. Then for 1 it will be 1, and then for 2 4, and then 3 9 4 16. So let's see what happens. As you can see here, this is the result that I wanted. So just to summarize, let's go through some key points to remember when it comes to list comprehensions. So it's obviously an elegant way to define and create lists based on existing lists. It's more compact and faster than normal functions and loops. But we should also keep in mind that we shouldn't write like very complicated list comprehensions, because the idea of a list comprehension is to be user friendly. And also it's important to note that every list comprehension can be written in the form of a loop, but every loop cannot be written in the form of a list comprehension. And that is probably a very key point to remember. So yeah, that's it for this video on list comprehension, set comprehension, dictionary comprehensions. I hope you learned a neat new technique or trick when it comes to creating your new lists. In this video, we will be learning about the concept of regular expressions. Now, a regular expression is simply a sequence of characters that defines a search pattern. For example, if you see this example here, you can see a symbol called the caret followed by P and then 5 periods, then an N and a $sign. And what this regex pattern does is it's searching for a 7-letter string that starts with P, ends with N, and has 5 characters in between. Let's look at this example now. This is a regex pattern that is looking for a 5-character string that starts with A, ends with S, and has 3 characters in between. Now, if we had to match this with this string, with these strings as our test strings, the first one would not match because it's a 3-letter string and we're looking for a 5-character string. The second one would match because it's a 5-character string that ends with an S, starts with an A, and has 3 characters in between. This will not match because what our pattern would do is it would find the first S, and it would find that the string itself starts with an A, and it would say, okay, there are only 2 characters between this first S and this A, and it would assume that this is actually just a 4-character string. To actually identify 2 consecutive S's, we would have to do something special, and what we would have to do is what we will see later on. So again, this is the same example. Since this is case insensitive, capital A is perfectly fine when we're searching for this, and it will also match. This is obviously 2 words, and it's not a 5-character string, so this will not be a match. Now the regex pattern, or the regular expression module in Python, can be imported using this statement, import re. Now once we've done this, we can actually use our regular expression tools and methods to do pattern recognition, character recognitions, and to identify different sequence of characters in our strings. Let's try to understand a bit more in depth about regular expressions now. So what you're seeing here is one variable called pattern, which stores something that looks like a regex, and another variable that stores our test string called abis. Now what we're going to do is we're going to use the match method of this module re, and we're going to check whether this pattern or whatever we are trying to search using this regex is in fact, does it match with our test string. And what we're trying to look for is, if you see here, very similar to what I just showed you, a 5-character string that starts with A and ends with S. So if you see our test string, it indeed is a match, and when we use this this command, we should get a perfect match. So we should basically it should say that search is successful if I execute this, and this is what it does. Now if I change the test string to this now, you will see that now this is no longer what we're looking for, a 5-character string with A and starting with A and ending with S, and you will see that the search will be unsuccessful, as you can see here. Now let's try to understand what exactly do we mean by when we use these special symbols, like for example this caret or this dollar symbol. These are, by the way, known as meta characters, and now we're going to look into all the or most of the different meta characters that are used in regex. So to put it simply, meta characters are simply characters that are interpreted in a special way by the regex search engine. Now here's a list of meta characters. Let's go through them one by one. Now the square brackets. Square brackets simply specifies the set of characters that we wish to match. So we want to match some combination of A, B, and C. It can be 1A, 2A's, 3B's, 4C's. We are not looking at a specific pattern. We just want to know if A, B, and C exists in any form in our string. So if we used it on A, the string A simply, we would find one match because the letter A is found here. AC would match twice because we have A and C present here. In this string, Hey Jude, we will have no matches because A, B, and C, none of them are found here. And in this weird string, we will have actually 1, 2, 3, 4, and 5 matches. So we would have 5 matches for this this bigger string because we have 5 instances of A, B, or C. Now let's use re.match to actually search for this and to see if we have our particular whatever patterns that we're looking for. Now in this input string, this is just some example string. I'm going to test this. I'm going to match whether my pattern that any of A, B, and C, is it actually found in this. So let's see what happens when I use re.match for this. So the format, the syntax is simply the regex pattern and then comma whatever test string that we have. So let's see what object gets created when we try to do this. As you can see, it's none. Even though you might be wondering, like I can see an A over here, I can see a C over here. re.match actually gives us the result none. Now, if I try to do it on this test string, which is slightly different, instead of the film Titanic was released in 1998, what I'm saying here is all film Titanic was released in 1998. Now let's see if the R-match works or not. As you can see, it actually does return. When I execute this, it returns us an object called re.match object with a span 01. The span 01 is basically telling us that we have found a match between the 0th and the first character, which is basically this character A, which is what it has found. And it's saying that the match is indeed the character A from amongst these options. So what this is basically telling us, and what this means actually, is that the re.match method will only find matches if they occur at the start of the string being searched. Once there is a space in our bigger string, it will not search for whatever comes after it. So what happened in the first instance was, it was actually only searching for matches in this particular word in my largest string. And since it found no match, it basically gave us the result none, which was not the case in the second example because it found a match immediately in the first letter A. Now if we want to actually check the whole thing, what we would be using is the re.search. As you can see here, the re.search method will actually check the whole string, and it will return us the first instance where it finds a match. Now let's see, this is the test string now, and we're searching again for we're searching for A, B, and C, any of these in our test string, but we're going to use re.search and not match. So now if you see, it returns us, when I execute this, it returns us a match object again, but this time it's saying the span of 9 and 10. Now the span of 9 and 10 actually exists over here. This is the 9th character and A itself is the 10th character over here. So what this basically is telling us that the 10th character is where we found a match, which was the letter A, which was the first instance of either A or B or C in this whole string. And this is basically how re.search works. It will not only search the beginning of the string, but it will search the whole string and return us the first instance of wherever we find. Now what if we wanted to find out all the instances wherever A, B, and C were found and not just the first instance? Well, in that case, we would be using the method findAll over here. So when we use findAll, it will actually return us each and every case where it found A, B, or C. And you might not, it won't tell you the exact position, but it will tell you like, so if I execute this, you can see it gives us a list with A, C, A, and A. And what this basically means is it was looking for the characters A or B or C, and it found A first, and hence this for the first item in the list. And then it found a C, and then it found two A's successively. So this is actually how findAll works, where it will actually find all of the instances of our regex pattern. Now that you've seen how the square brackets work and how the re.search and re.match and re.findAll methods work, now we're going to go through all the other meta characters that we saw above. So the period. Now period matches any single character except the new line. New line is basically /n or a break. Now if you look at this picture, what it's going to do is this expression basically saying that do we have two characters, like sets of two characters in our string. So this is a single character string, and obviously a single character string is not a double character string. And this expression, this double dot, is basically asking us, do we have two characters present in our string? So if I had to match it with this A, it will obviously be a no match because A is one character. If we checked it with AC, it is a match because A and C are two characters. A, C, and D will also give us only one match because it will find A, C, and then it will leave D as a single character. But when we check A, C, D, and E, or this string in particular, it will find two matches because it will consider A and C as one of the matches and D and E as one of the matches. So below is basically what we're doing. Basically the same thing, we're just using re.search for each of these different examples. So if you see when I use findAll on A, C, D, E, and when I'm searching for a two character match, you will see that it will return me A, C, and D, E, as you can see here. And similarly for something like this, it will return me again whatever like two character patterns it finds successively. So the next symbol, the next meta character, is the caret symbol that you've seen earlier. Then the caret symbol is basically used to check if a string starts with a certain character. So if you look at this picture, we have two expressions that we're going to check over here. One is checking if A is the beginning of a string, and the other one will check if A is the beginning of the string, but is it followed by B or not. So when we check this, what you can see is the first string will be a match because it's only the character A, and it will match here as well because this string starts with A, but it will not match here because this string starts with B. Now if I look at this particular expression, you can see that this is going to search for if the string starts with A and is followed by a B. So it will match in this case because it does start with A and is followed by a B, but it will not match in this case even though it starts with an A because it's not followed by a B. So out here is basically us using the re.search to basically find these patterns. The next symbol that we will come across is the dollar symbol. So the dollar symbol that you can see here is used to check if a string ends with a certain character, and we have already seen how this is used in one of the earlier examples. So this is going to check basically this expression will check if the string ends with A. So this string is basically the character A, so it will match. This also ends with A, so it will match. And this particular string does not end with A, so it will not match. And we are going to do that using the re.search over here. So as you can see, it finds a match in the first character itself here. In this case, it finds a match in the last character, but in CAB, there is no match, so it returns us a none. Another example is of the meta characters is star. So this is the symbol for star, and what the star basically is used is for checking if there are 0 or more occurrences of the pattern to the left of it. So now if you see here, what this will check for is there any form of m and a that occurs before n? And it's very important to note that the n has to follow the a in this case. So let's look at these examples and what will happen. So if I checked it with m and n, this is actually a match because n is followed by 0 occurrences of m and a, which is, it might seem a little weird, but it is technically the truth, because the star symbol doesn't check for the existence, it just checks for if n occurs, it must occur after an a, or the a should not be there itself in this particular string. So as you can see here, the n occurs after an m, and it's fine because there is no a. Now you will see when it will not work. So m, a and n is obviously fine. M triple a n is also fine because n follows an a and there's an m here. This, however, main will not match. Now why? Even though we have m and a and we have an n, you see the n is immediately followed by an I. N follows an I immediately, or the n is preceded by an I immediately. And this is a no match because the strict condition in the search is that n must precede an a if the a exists. Again, in woman it will match because n follows an a over here. We're just going to use the re.search for these examples that we saw over here in terms of code using the re.search, as you can see here. Finally, we have the next meta character, which is the plus symbol. Yes. So the plus symbol matches one or more occurrences of the pattern left to it. Now this is very similar to what we saw earlier in terms of the star, except now in the plus, the key difference is we're looking for one or more occurrences instead of 0 or more occurrences that we were looking for in the case of star. So when we say one or more occurrences, now we need what is there to the left of the plus sign. A 0, no occurrence of it will not be allowed or will not cause a match. So let's see now what we're going to do here. We're going to use the same expression, except we're going to replace the star with the plus sign. So now what we're going to say is, okay, we need m and a, at least one occurrence followed by an n. All of these conditions have to be met. So again, if we took the first example, m and n, this time it will be a no match because there is no occurrence of an a over here for preceding the n. So it's a no match. M, a and n is a match because, well, this is perfectly fine. M triple a and n is also perfectly fine. But if you look at m, a, I and n, much like earlier, the n is preceded by an I and not an a, so there is no match. And again, woman is perfectly fine. And we basically execute the same thing through the search function in this piece of code. The next meta character is the question mark. The question mark symbol matches 0 or 1 occurrences of the pattern to the left of it. So let's see what this does. So now we saw the star which was 0 or more occurrences of the pattern to the left of it. We saw the plus, which is 1 or more occurrences of the pattern to the left of it. Now we will see the question mark, which is 0 or 1, only 0 or only 1, and not 0 or more or 1 or more, which was the previous cases, only 0 and 1 or 1 occurrences of the pattern to the left of it. Again, we're going to see the same expression, except we're going to replace the meta character with the question mark. So now let's see what happens when we match. So if you see here, m and n is a match because there is 0 occurrence of a and 1 occurrence of m preceding n. So this is fine. This is also fine because there is 1 occurrence of a and m, and then it's followed by an n. This will not be fine because now we have 3 occurrences of a, which is followed by an n. We're only looking for 0 or 1. This again, main will be a no match for the same reasons that we have already gone through, and woman will be a match again for the same reasons. And we do the same thing using the search function in this piece of code. The next meta character is the braces character. Now the braces character is interesting because what we're going to do is we're going to see if there are, the typical syntax for a braces is n brace followed by some integer n, comma, integer m, and then close braces. So what this means is we're looking for at least n and at most m repetitions of the pattern left of the braces. Let's see through an example. If you see this expression, we're looking for at least 2 and at most 3 occurrences of the character a in our test strings. So let's see what happens in the first case. We have no matches in this case because this part of the string contains only one A, and even this part of the string only contains one A. We're looking for at least 2 and at most 3. This part will contain one match, the second example, because the second part of the string actually contains 2 A's for two repetitions of A's consecutively. But this in the third example, you can see both the strings actually contain matches. So we get 2 matches because, as you can see here, there's 2 A's here followed by 3 A's here. Now when we look at this particular string, let's look at what happens now. So what we're going to find is that this string is perfectly fine. So we have 2 occurrences of A, but now we have 4 occurrences of A. But what the search engine is going to recognize is these first 3 A's, and it's going to see, okay, so there are 3 occurrences of A and I already have a match. It's not going to consider this 4th A in the search. It will just look at the first 3 and it say, okay, there are 3 A's and my match is fine. So again, there are 2 matches in this case. Again, we're going to use the search function initially, and you can see in each of the cases there is a match except for the first case, which is this case. Now let's see the find all option and see what happens when we do the same thing using find all. So when we use find all, it basically gives us each of the instances where the match has occurred in each of these lists. Now let's try to use a slightly more complicated example where we combine different meta characters and we create a more sophisticated expression that we want to search in our test strings. So if you look at this expression, what we're looking for is 0-9. Now a dash symbol is valid in Python using regex because what this basically tells it is that it's looking for either 0, 1, 2, 3, 4, so on until 9. Basically any of the digits. We're looking for any of the digits from 0 to 9. And we are going to check if at least 2 and at most 4 occurrences of digits, if they are there or not in our particular code. So let's see what are the matches that happens when we use it on test strings. So if you use it on this string, you can see it will find one match. This particular part of the string where it says 1, 2, 3. So this is 3 occurrences of digits, so it's fine. Now when we look at this whole string, 12 and whatever this is, you will see this will not find a match here. This obviously will not because these are characters. But if you look at this part, it will find matches in terms of the first 4 and then 7 and 3, the next 2. 1 and 2 again, there are no matches because there's only single occurrences of digits. We're looking for at least 2 and at most 4. So if I use a find all, you will see like what all it will return. So for the first test string, what it's going to return me is, it's going to return me 1, 2 and 3 as you can see here. But now if you look at this test string, it's going to return me 12. It's going to return me 3, 4, 5 and 6. It's going to return me 3, 4, 1 and 2, but not 7 because we're looking for at least 2. And then it's going to return me 4, 5, 6 and 7 followed by 8 and 8 as you can see in this list over here. Now if we use curly braces with only one digit, it's basically telling the search engine that we want exactly so many repetitions of the preceding whatever expression that we have. So when we do this example, for example, we are basically saying that we want x followed by a dash, and the dash has to occur at least 3 times in our particular expression, and then it should be followed by an x again, which will not match in this case because there are only 2 dashes, and it will match in this case because there are exactly 3 dashes, and it will again not match in this case because there are 4 dashes. As you can see here, none followed by an object match followed by none. Next we move on to the alternation meta character. And as the word suggests, alternation is basically looking for some alternate form of A and B. So A should be followed by B, and basically this pattern has to keep going on. So in the first string over here, this pattern will not match. In the second string over here, we will have a match because we at least find an A, even though there is no B. But this is still considered a match because we did find an A at least. Over here we'll have 3 matches because we have A followed by a B followed by an A again. So if we did a regex expression for this, we would basically find these many matches for each of these examples. The next meta character is the group. Now a parenthesis is basically used to group subpatterns. So let's look at an example to understand what we mean. Now if you look at this complicated expression, what this means is that I want some form of x and z. The x and z have to occur together. But before that, what I want is some form of A following B following C. Some sort of alternation between A, B and C. So this part, as you can see here, is kept in a parenthesis because I want this whole condition to basically occur before I find an x and z. So let's look at what happens here. In the first case, we don't have a match because this parenthesis condition is not being met. X and Z is preceded by a space, or basically the A and B is followed by a space. So if the space didn't occur, we would actually find a match. As you can see in the next example, here you can see A and B occur. Basically, this initial condition is met, followed by X and Z. So there is one match. So it's fine for us. Now, if you look at this slightly more trickier one, what you can see is we have two matches in this case. First an A followed by X and Z, and then we have C, A and B. Now, this is perfectly fine because we are looking for a B followed by an X and Z. We're looking for either of these things. We're looking for some form of alternation of these things followed by an X and Z. And we can get that over here. We get B followed by an X and Z. So you'll get two matches in this case. Now let's go through the concept of grouping constructs. Now that you've seen many meta characters, you've seen how parenthesis works. Let's look at grouping constructs. So grouping constructs break up a regex in Python into sub-expressions or groups. And this serves two purposes. One is the grouping part, which basically says that a group represents a single syntactic entity. And any additional meta characters apply to the entire group as a unit. And then there's the capturing part, which basically tells us that some grouping constructs also capture the portion of the search string that matches the sub-expression in the group. And you can retrieve captured matches later through several different mechanisms. So let's look at basically what we mean by this example over here. So if you see this expression has a plus sign. So we're looking for, as you know, a plus looks for one or more occurrence. So this will basically check for one or more occurrence of the character R only, because there's no parenthesis as in this example. So this plus is next to an R, and it's going to check for basically whether one or more occurrence of R happens preceding B and A. But if we actually put B, A and R in a parenthesis followed by plus, it will actually check for the entire string BAR, and it will check one or more occurrences of BAR together. So if you look at these two examples, when we use this on these examples, you can see that these are fine, like these matches are fine. But if I used this parenthesis, then these would be the acceptable matches. And like BA triple R would not be a match if I use parenthesis, as you can see here. So this is how grouping constructs work and how parentheses work. So look at some other examples. So what this will do is FOO has to be optionally followed by BAR, and BAR must exist together. And this is because we have a question mark here. This question mark symbol tells us that it should be 0 or 1 occurrences. Similarly, this particular complicated expression is checking for one or more occurrences of whatever we saw earlier. Basically, this whole thing is followed by a plus. So we're looking for this whole sequence for one or more occurrences of it. COW is simply just COW. We're looking for this pattern. And this is going to check for 0 or 1 occurrence of COW because of the existence of the question mark preceded by the parenthesis. In this video, we're going to continue our discussion on regular expressions. Now that you know the basics of regular expressions, let's continue our discussion with special sequences. Now, in an earlier video on strings, you might have encountered what is an escape sequence and how we use the backslash character to generate these escape sequences. And an escape sequence is basically, if you remember, something that we use to either give a certain special meaning to characters that are otherwise ordinary, or it is used to remove the special meaning that are inherently present in certain characters that we call meta characters. So let's look at what special sequences are in relation to regular expressions. So the first one we're going to look at is the backslash capital A, which is used to match if specified characters are present at the start of a string. So out here, if you can see, we are checking if the word the is present in these two strings. So we would get a match in the first case over here because this starts with the word the, but in the second case we won't get a match. And this is how we're going to check it for the same thing using the findAll function. So if you see in the first case, it returns us an object because we do find the in the beginning of the string. In the second case, we get us empty list because this string does not start with the word the. Now the next one that we'll look at is backslash b, small b. Now this is used to match if specified characters are at the beginning or at the end of a word. So when you use backslash small b and then you follow it up with whatever you're looking for, it would look for those particular characters or that pattern if it exists in the beginning of a word in a string. So if you look at the first example, it starts with FOO. And in the second example, you see this portion of the string or this word is actually also starting with FOO, so it will also match. However, in this string, which is very similar to the second one, we don't have a space between A and F, and it's basically one word. So this does not start with FOO, but it actually starts with AFO, and it won't match, as you can see here. Now similarly, if we wanted to check if something exists in the back of a string, at the end of a string, we type what we want to search for first, and then we follow it with a \b. And if you see here, it will match in this first case, it will match in the second case because this part of the string ends with FOO, but it will not match in this case because, well, we removed the space, so now this whole thing becomes the string that we're looking for, and it does not end with FOO anymore. And this is basically us just checking it through the findAll function. Now the next special sequence that we will be looking at is the /B, which is basically the opposite of what we just saw. This matches only if the specified characters are not at the beginning or the end of a word. So if you see here, this is checking if FOO is not at the beginning of these strings. So in this case, there will be a no match. In this case also, there will be a no match. In this third case, there will be a match. Similarly, if we wanted to see if something does not end with a particular string, we would type that whatever pattern we're looking for, followed by a \B. And then we can use the findAll function to generate us lists wherever we find such objects, find such matches in our particular test strings, like we have done over here. So the next one that we're going to look at is the \d. And this matches any decimal digit, which is equivalent to doing a square brackets 0-9. As you must have seen earlier. So if we did a square bracket 0-9, and if we did a search or a findAll or a match, it would look for any of the digits between 0 and 9. So a similar thing can be done using a special sequence \d. So as you can see, there will be 3 matches in this case because 1, 2, and 3 digits exist. Whereas in this case, for the word Python, there will be no matches. So these are certain examples where we are doing the same thing using the \d. Now we have another one, which is the \D, and this is just basically the opposite. It matches for any non-decimal digits. It's also equivalent to typing a caret inside square brackets with 0-9, which, if you remember from the previous video, is basically asking us to check for anything that is not the digits 0 to 9. So this is basically, we're going to check in these two strings if there is no digits, no non-decimal digits. So if you see here, we will find 3 matches, A, B, and the double inverted commas. And in the second string, we will find no matches because this is fully just digits. Next, we have \s. Now this matches where a string contains any white space character. So this is equivalent to doing a check for all of these. So this is like \t is a check for tab space, \n is a check for break line, and then /r, /f, /v are their own checks for different sorts of white space characters that you can see by just looking it up, honestly. But yeah, so if you simply do a \s, it would actually be the equivalent of searching for any of these white space characters that we generate. So if you see here, when we do a \s on this string, you can see that there is one space over here. So it will match, it will give us one match because there is one white space, which is just the normal space here. And in the second example, there is no match because there is no white space here. Similarly, /S now, as you might have noticed, is basically checking for a string which does not matches in a string wherever there is no white space characters. So it's basically the same as doing caret /t, /n, /r, /f, /v in a square brackets. So this is basically a simpler way of doing the same thing using square brackets and a caret symbol. So if you see this expression, \S, now we're looking at A space B. So over here, if you see, it will match for all the non-spaces. So it's going to match for A and B. So we're going to get 2 matches here. Whereas an empty string does not contain, well, it does not contain any non-white space character, since an empty string is basically a white space character on its own. So this will give us a no match. So the next special sequence that we're going to look at is the \w. This matches any alphanumeric character, which is the equivalent of doing A to Z in small and then capital A to Z, and 0 to 9 and also an underscore check in square brackets. It's important to note that the underscore is considered an alphanumeric character, hence why we include it over here. But yeah, this is the \w, small w, which basically checks for any alphanumeric character and matches it in a string. So if you see in this first case, it will find 3 matches at 1, 2, and also at the letter C. These others are not alphanumeric characters. Whereas in this string, none of these are alphanumeric characters, so we will get no match. Again, much like the other examples, there's a backslash capital W, which will check for any non-alphanumeric character. And it's the equivalent of doing whatever we did before in the square brackets, just with preceded by a caret sign. So if you see here, we have this string where we have a bunch of characters. Well, yeah, only one of them, this percentage symbol, is a non-alphanumeric character. So we will get one match over here. But in this case, in this string Python, we will get no matches because they are all alphanumeric characters. We're just doing the same thing here with a bunch of different examples using the findAll function. Now the backslash capital Z matches if the specified characters are at the end of a string. Now don't confuse this with backslash small b, because the backslash small b checks for a string and it checks each and every word in the string individually and checks if any of the words ends with a particular thing or starts with a particular thing, but it checks each word individually. But in this case, a backslash capital Z will check the string only and not each word. So if you see the difference here, when you use backslash capital Z, it will match in this first example, but it won't match for the next two. But if you used backslash small b over here, it would actually match not only in the first example here, but it will also match in the second example, because it would check this word individually and it will find out that, yeah, there is a match here as well. So it would actually match in the second example as well. In this video, we will be covering the topic of serialization in Python. Now, object serialization is very simply put, when we want to convert a data structure or an object type, and we want to translate this into a form that is that can be stored in a memory, such as a file or a memory buffer. Later, we could deserialize this particular file and reconstruct the original object out of it. Now in Python, this is done, object serialization is done by converting the state of any object into a byte stream. This byte stream can be further stored in any file-like object such as a disk file or memory stream. It can also be transmitted via sockets. Deserialization, as I mentioned earlier, is the process of reconstructing the object from the byte stream. Now in Python, we refer to the serialization and deserialization by the terms pickling and unpickling. So the pickle module, which is a module that is a part of the standard library of Python, it provides functions for serialization, such as the dump and the dumps function, and also for deserialization with load and loads. The data format of pickle module is it's very Python specific, and so programs that are not written in Python may not be able to deserialize the pickle data properly. And it's also considered unsecure to unpickle data from unauthenticated sources. So in this example here, what I'm going to do is I'm going to take the dictionary object, which is represented by DCT, and its byte representation will be stored in a file called pickled.txt, and we will also gonna enable the write and binary mode preemptively. So if you can see here, first I'm importing the pickle package, and then I'm opening a file pickled.txt and write in binary mode. Then I create this dictionary, and I'm going to dump this dictionary into that particular file, and then I'm going to basically close the file. So this executing this would do this. Now it's important to note, a pickled file is not a human readable file. A computer can understand this, but it's so the byte representation of any object or data type cannot be read by a human in plain sight. So this next part is where I'm going to deserialize, or I'm going to unpickle the file pickle.txt. So again, I'm importing pickle. I'm opening this file in read and binary mode, and what I'm going to do is I'm going to load this into D. This will basically, in a way, deserialize whatever was there in pickle.txt. And once I have unloaded it in D, I'm going to print what's the content of D, which should be my original dictionary itself. So when I execute this, you can see that printing D prints my original dictionary that we had before. And it's important to note, since dictionaries are unordered, so dictionary objects don't retain the order of insertion of keys. So the way we enter the keys inside the dictionary when we create it is not maybe the same way that we will see the order of the key value pairs when we actually unload it. Now there exists a dumps function inside the pickle module, that pickles Python data to a string representation. So we're going to do that in this next piece of code. So I'm importing the dumps function from the pickle module, and I have my same dictionary. What I'm going to do is I'm going to dump this dictionary into dct string, and I'm going to print dct string to show you like what exactly a string representation of this dictionary would typically look like. So when you execute this, you see this something very cryptic. So this is basically what we mean by string representation. Of course, we can use the loads function again to unpickle whatever we just did and get the original dictionary representation of this particular string. So that's what we're doing in this piece of code. And as you can see, we get back our dictionary over here. So now in our second example, what we're going to do is we're going to create slightly more complex data structures, and we're going to do some serialization, deserialization on them. So we have this function called store data, where we initialize two dictionaries called Omkar and Jagdish with some certain key value pairs. Now we create another dictionary, empty dictionary called db, which will be like our database. And now this db has two keys again called Omkar and Jagdish once again. And now if you notice, my new keys are Omkar and Jagdish, but their values are these new dictionaries again. So we're basically storing a dictionary within a dictionary, so as to speak. So once we have done that, what we're going to do is we're going to create another file called example pickle, and we're going to create it in binary mode. Now once we've done that, we're going to dump this dictionary db into this file called db file, where we have opened basically where we're going to store the serialized representation of this dictionary called db, and then we're going to close. So this is what store data will do when we call this function. And in load data, what we're going to do is we're going to print out what each key and what it represents. So we're going to basically deserialize in the load data function. We're going to deserialize whatever we just serialized in the previous function. So when we execute this, we should basically get something like Omkar followed by this sort of an arrow sign, and whatever the dictionary that we have assigned to Omkar is. Similarly for Jagdish as well. So when we do store data, it will basically do the serialization process. And when we do load data, it should do the deserialization and print out the the DB dictionary that we created in store data over here. So let's execute these two. Oops, I did not execute the load data. So now it should work. Yeah. So if you see now when I have executed load data, I get back. So basically from store data, I first serialized my whole file into a particular file called db file. And once I've done that, I have deserialized it using the load data function over here. In this video, we will be covering the topic of Python partial functions. Now, partial functions allow us to fix a certain number of arguments for a function and generate a new function. The functools.partial module helps us achieve this. Now, let's say we want to create a function that explicitly performs exponentiation. So we can get squares, cubes, and other power operations on any number. So let's look at an example. So we create this function called power, where we have a base and an exponent. So what this does is it will basically print some number which is the base to the power of some exponent, and the result which will be returned over here. So let's see now, what if we want to create a dedicated square and cube functions that leverages this. So we can define a square function called with an argument called base, where we return the power of the same base to the power of 2. So we're defining a square function with the help of this function that we defined already called power. For cube, we will basically do the same power function, but the exponent will be 3. So now when we do square 10, we're going to say, if we executed all of this, so now if we say square 10, what this will do is it will say 10 to the power of 2 is 100. And if you see the next one, cube 5 to the power 3 should be 125, as you can see here. Now this works, but what if we want to create say 15 to 20 variations of our power functions, and what about say 1000s of them? Defining a function for each case is obviously very repetitive, it's annoying, and this is where we will find partial coming into play. So and as an example, let's do the same thing. Now what we're going to do is we're going to import partial from the module called functools. We have what we're going to define is this function called square, which is basically going to use the partial functions operation for the power function with the exponent of 2. So what we're doing is basically we're going to use the power. We're going to reference the power function that we defined earlier, but we're going to pass the argument for exponent as 2. And for cube, we're going to do the same thing, but exponent is 3. So once you've defined this, if we do square 2, you get the result as you can see. For cube 2, you get the result as you can see here. Let's look at another example. So we have this function where we define some function with 4 arguments. Now what we're going to do is argument a, b, c and x, right? So we're going to return 1000 times a, 100 times plus 100 times b plus 10 times c plus x. Now we're going to create a partial function that calls this function, but it's going to use a as 3, b as 1 and c as 4 always, right? And so how we do that is basically g is equal to partial like this. So once we've executed these, now if we say g10, we basically get the value for 1000 times, well, 1000 times 3 since a is 3, plus 100 times b is 1, so 100 times 1, plus 10 times, well, c is 4, so 10 times 4, plus x. Now x we passed as 10, so the result of all this will be 3150 as you can see here. Now let's look at a final example where I've defined some function called add. I have 3 arguments, a, b and c. What I return from this add function is 100 times a plus 10 times b plus c. So let's create a partial for using partial functions where b is 1 and c is 2. So we have this fixed. We can create a partial function called add part. So what this does is it takes the add function, it creates a partial function out of it using c is equal to 2 and b is equal to 1. So now when I print add part 3, what happens here is 3 gets passed in the form of a. So I get 3 times 100, and since b is fixed as 1 and c is 2, so I get 3 times 100 plus 1 times 10 plus 2. So it should give me 312. So when I execute this, you can see this here. In this video, we will be covering the topic of closures. Now, before we understand what a closure is, we have to understand what is a nested function and non-local variables. Now, a function which is inside another function is known as a nested function. Nested functions are able to access variables of the enclosing scope. So if I define this function called outer function, where I pass some argument called text and I store that in a variable called text again, and if I create a function within this called inner function, and I want to print whatever this variable is in text, when I execute this, it will be able to access this variable because it's within the enclosing scope. So if I said outer function hey, this gets stored in the variable text, and then the inner function will print that variable, which is basically the string hey, as you can see here. Now, inner function can easily be accessed inside the outer function body, but not outside of its body. So here, inner function is treated as a nested function, which uses text, this variable text, as the non-local variable. Now, a closure is a function object that remembers values in enclosing scopes, even if they are not present in memory. It is a record that stores a function together with an environment. It's a mapping basically that associates each free variable of the function, which are basically variables that are used locally, but are defined in an enclosing scope, with the value or reference to which the name was bound when the closure was created. A closure, which unlike a plain function, allows the function to access those captured variables through the closure's copies of their values or references, even when the function is invoked outside the scope. So let's look at an example to emphasize on what was just said. So again, I've defined this function outer function where I'm doing the same thing. Now I've defined the same inner function where I'm going to print the same thing. Now it's very important that when I return over here, what I'm going to return is inner function, but it's not going to be a function call. This is important to create our closure. So we return inner function, but without using the call as we do over here. And what this return will do is basically to create the closure, where the inner function will remember the values of the variables stored in the enclosing scope. So now I'm going to store this outer function in an object called in a variable called my function. Now when I call this my function, you can see there'll be two things that are happening here. So once I've defined this and I've executed this, what happens out here is this function has already executed, and then I'm storing it to this. But because I've done return inner function without parentheses, I've created a closure basically. And this closure allows the inner function to remember the values that were stored in text at any point, and at every point, even after the execution of this one time. So when I execute this again for the second time over here, it will remember the value that was stored in the variable text, which is hey, which was given over here. That's why you see when I execute it for the second time over here, the first time being in this line when I'm storing it in my function, when I execute in the second time, again it will give me the result of hey. As you can see, the closures have to invoke functions outside the scope. The function inner function has a scope only inside the outer function, but with the use of closures, we can extend its scope to invoke a function outside the scope. So now let's look at this code. So this code, don't worry about what's going on here. Just know that what we are doing here is we have two functions which we defined called add x and y, which will return x plus y, and the subtract function, which will subtract x and y. So now we're going to execute these. Once we're going to execute the add over here and add logger, and we're going to execute the subtract function, and we're going to store it in sublogger. So technically we have already executed these two functions, but now since I've created an enclosure, basically if you see here, this is the enclosure that I've created. Now what happens is when I access this function from outside its initial scope, which is basically over here, this was the initial scope. When I access it outside, you will see that it still has access to these variables x and y. So if you see here, I first of all I've allowed the enclosing function to accept arguments of any numbers. So I can pass x, y, I can pass x, y, z also. But if you see here, I only have a thing for x and y. So when I want to access any value of x and y, even after the execution of this code initially, I have access to these variables x and y, and that is because I've created a closure out of that. So if you see, if I do add logger 3 and 3 over here, I'm able to get the result 6. If I do add logger 4 and 5, I'm able to get the result 9. Similarly, for subtraction logger 10 and 5, I will get 5 here, and 20 and 10, I'll get 10 here. And I can keep doing this. I can keep saying add logger, and if I say 4 and 7, so if I executed this, and now I'm going to say, let's say for example, add logger, if I said 4 and 7 here, so this still has access to my variables x and y because I've created the closure, and it should give me 11. Similarly, if I did sublogger, say 30 and 15, it should give me 15 because 30 minus 15. So let's say 30 minus 16, right? So it should give me 14 because again, I have created the closure and it has access to these variables already. In this video, we are going to be learning about the topic of decorators. To start off with, let's first understand some basic concepts. Now in Python, we know that functions are first-class objects, and that means that functions are objects and they can be referenced to, and they can be passed to a variable, and they can be returned from other functions as well. Functions can also be defined in another function and can be passed as an argument to other functions. So decorators allow programmers to modify the behavior of a function or class. Decorators allow us to wrap another function in order to extend the behavior of the wrap function without permanently modifying it. Now, any generic functionality that you can tack on to an existing class or function's behavior makes a great use case for decoration. Some of these include rate limiting, caching, logging, enforcing access control and authentication, instrumentation, and timing functions. Now you have to remember that function names are references to functions and that we can assign multiple names to the same function. So for example, if you see here, I have defined a function called success, which does basically you pass an integer and it returns 1 plus that integer. So if I do success 10, it should give me 11, as you can see here. Now if I'm going to say successor is equal to success, I've basically created another function called successor which does the same job as the success function. So now if I pass 20 to successor, it should return 21, as you can see here. So as you can see that we have two names, success and successor, for the same function. An important fact is that we can delete either any of the functions, and you won't delete the other one. So if I said delete success, and if I tried to pass 10 to the other function called successor, it would still execute the whatever task the function is supposed to do. Now let's look at an example of a function inside a function. So I've defined a function called f, in which I have defined another function called g, which has two print statements that you can see here. The function f itself has two print statements, and at the end of the execution of function f, we call this function g. So let's see what happens when we actually execute f. So let's look at it on this side. So if you see here, this is where I've defined it. Now let's call my function f and let's see what happens. As you can see, first when you execute function f, it will create this function and then it will print these functions and then it will do a call to this. And when we call this function g, it's going to do two of its own print statements, as you can see in this order over here. So this is an example of a function within another function. Let's look at another example of something similar. If you see here, I've defined a function called temperature where I can pass some value for T, and I have defined another function within this called Celsius to Fahrenheit, and basically I'm doing the conversion. So when I execute this, what it should return me is I'll pass some temperature and it will return me the temperature in degrees. So for example, in this case I have passed temperature 20. So let's see what does it pass, what result does it give to me in degrees. As you can see, it says it's 68 degrees. Now let's look at another example of a function within a function, for a very common example for the factorial function. So if you see here, I've defined factorial n, and I'm saying if the value that is passed in n is equal to 0, return me 1. Otherwise, return me the product of that number times, and I'm going to do a recursive call back to the same function, except now I'm not going to pass n but n minus 1. So what this should do is, if I pass 10, for example, it will basically check, okay, since 10 is not equal to 0, it will go here. And it will return me 10 times factorial of 9. And that will do 10 times 9 times 8. And then so on until we reach n is equal to 0, where it will just say, okay, return 1. So what you will effectively get is 10 times 9 times 8 times 7, so on until 1, which is basically factorial of whatever we have passed. So let's execute this. See, I'm going to check what is the factorial of 5 here. And as you can see, it gives me 120. Now let's include a line, let's raise an exception by an else statement, which will basically raise a type error, and it will tell me that if I pass a number n which is not an int, and if it's not greater than or equal to 0, it should give me this error message. So I have included this extra statement in this just to check. So if I pass 9, as you can see, it should give me a valid result, which is 362880. Now what if I pass minus 5? So let's execute this. As you can see, I get the type error that I have raised over here in case I meet such a condition. And in this case, you cannot find the factorial of a negative integer. So that is why my type error gets raised over here. If you actually look closely at this program, you will notice that each time I call back my function factorial, so if I gave it 5 initially, it will check for the this condition, and since it will meet the condition, we can continue. But the next time when we call factorial for 4 and then for 3 and 2, each time is going to do this check. That's kind of redundant because we know that if we passed 5 in the beginning, until we decrement it to 0, we're going to only get the valid numbers 5, 4, 3, 2 and 1. So we don't need to do this check at every point. We just need to do one check. So a workaround for this would be in this code that I've written over here. And in this, I've basically defined a factorial function called n, where I'll pass my integer initially. And within that, I've defined the actual function where the actual results will be calculated, and that's called inner factorial. This is where this is basically the actual factorial calculating part. And if you see this if statement block, this is my check. So this will basically be the only check that will happen. So out here, it will check whether the n I have passed is a valid integer and equal to or greater than 0. And if it is, then we will perform this inner factorial function, where we won't be doing any more such checks. We will only calculate the factorial. And if it's not, then we will raise this exception just once, and we will exit the program in case we've given a wrong number. So let's look at an example for 3. So as you can see, at each step of my calculations, I'm going to return whatever value I have at that point. So basically, if I give 3, you will notice that you will get 0, 1, 2, and 6 if you multiply it in the right way. So let's do this. As you can see, factorial 3. One second. So I have to execute this. Now if I execute this, you can see I first get, because initially it will check, when I move into inner factorial, it will check if n is equal to 0. It will basically return whatever value I have at that point. So basically this is the order of calculations in a backward way. So you can see here it will first be 1 and then 1 times 2 and then 2 times 3, which is 6, which is what we get. So don't worry about the order in which we are returning these values. This is basically just a reverse way in which the program will fetch our values. So yeah, this was basically how we reduce the redundancy in the check part of our function. Now let's look at some examples where a function will be returning another function. So as we know, the output of a function is also a reference to an object, and therefore functions can return references to function objects. So out here, if you see, I've defined a function called f, which will take a parameter called x, and then within it I've defined a function called g, which will have a parameter called y. And this g will basically return y plus x plus 3, and the function f itself will return the function g. So if I pass 10 in function, so what this will do is it will create a function called g. I will create an instance of a function called g, and that object is going to be returned to us because we basically returned g when we call function x, right? So if I execute this, you will see that when I say f10, it will give me some object location of a function called g. Now if I want to see the result of what I get for this function g, I have to pass something within g itself. So out here, what I'm going to do is I'm going to store this function object in a variable called nf1. Once I've done that, I can pass another parameter for this nf1 object. And since we know this nf1 is a variable name for the function g, so when I pass nf1 20, I'm basically passing this y parameter. So since now I have passed 10 for x and I have passed 20 for y, oops, one second, yeah. So what I will get returned is 20 plus 10 plus 3, which is 33. When I do nf1 and I pass 20 as the parameter here, as you can see, I get 33 over here. Now let's look at a function where we will implement polynomials of degree 2, and then we will actually extend that to polynomials of any degree. So I have created a function called polynomial creator, where I pass 3 arguments which will represent the coefficients. So a will represent the x square coefficient, b will represent the x coefficient, and c the constant. So I have defined within this, I've defined a polynomial function called x, where I will pass my value for the variable x, and I want to get returned the value for this polynomial. So as you can see here, initially the first function will return this object, and then for this object itself, I will have to pass another argument where I'll pass the value of x. So I'm going to create 2 instances of this polynomial function. In the first instance, my coefficients are, as you can see, 2, 3, and minus 1. In the second case, it'll be minus 1, 2, and 1. So once I execute this, oops, let me execute the function initially. Yeah, there you go. So if I execute p1, it will basically give me a object location of the polynomial function for p1, which is represented by this basically. So now what I'm going to do is I'm going to iterate through values between minus 2 and 2, not including 2, at steps of 1. So I'm going to iterate for minus 2, minus 1, 0, and 1. And I'm going to say, initially print me the values of x that I'm going to pass in this column, this first column. And then I'm going to say, okay, what are the results for the first polynomial object where the coefficients are 2, 3, and minus 1. And then in this column, give me the values of the polynomial with these coefficients, minus 1, 2, and 1. So when I execute this, as you can see, these are my results. Now, what if I wanted to do the same thing for arbitrary coefficients, as in a polynomial of nth degree? I'm not specifying the exact degree. So this I can do with this slightly more complicated program, which is actually very simple. So if you see this function, I've defined a polynomial creator function again, but in this case, I have passed variable number of arguments. So this asterisk basically means I can have any number of arguments here, and this will be an iterable with any n number of objects that can be iterated upon. So, and that will be called coefficients. So within that, again, I've defined polynomial x. Now what I've done is I've initialized some variable called res, which will basically be my result variable. And what I'm going to do is I'm going to for loop through this coefficients iterable. And what this basically does is, in a backward way, this is basically going to iterate through the array or the list or whatever we have of coefficients in a backward way. So if I pass 6, 7, 8, 9, it's going to give me 9, 8, 7, 6 in that order. And what this enumerate function will do is, it will assign an index to each of the values and coefficients. So for example, I can just show you over here what this means. So if I created a array called say coefficients with some random values over here, right? Now if I'm going to perform this line, right? Now let's see what happens when we do a for loop. Let's see what values we get for index and when we do this, execute this line. So if you see here, now once I execute this, as you can see, what I have done is coefficients. Oh, I made a spelling mistake. This is taking from a different variable. So let's fix this. So as you can see, I've entered 4 objects, 4 integers, 1, 23, 4, and 45. And when I do this for loop, I basically want to assign some index value 0, 1, 2, and 3 to each value in this list, but in a backwards manner. So this will be the 0th item, this will be the first, this will be the second, this will be the third. So that's what we are doing in this function as well out here. We're basically going to use this enumerate function to, now if you see this result is basically going to add each component of this polynomial. So if you see closely, what this is going to do is it's going to first, in the first step, is going to find out, well, what is the value of this, the constant term. And then in the next step is going to find out what is the value of this. And it's going to keep summing it up. It's going to sum this part up until the end. And then we will get our final result in this variable res, and we're going to return that over here. So if you see here, I've done the same thing. I've created 4 function objects, and they're called P1, P2, P3, P4. And now I'm going to iterate through again -2, -1, 0, and 1 as my different x values, and I'm going to see what are the different values for each of these polynomials. So if you see here, my first polynomial is basically, it has only 1 coefficient, so it's a polynomial of the 0th degree. So basically whatever I pass for x, that itself should be my result. So actually this is a polynomial of 0th degree, so this is basically the only result we will get. So the constant is 4, we will get 4 in every result. So if you see here, what I'm printing is the x values first, and what are their respective polynomial values for each of these objects that we've created. So this is a constant, so P1 will only have the result 4. This is P2, so this is a polynomial of degree 1. So it's like saying 2x plus 4, and where x takes values -2, -1, 0, and 1. And in this case, you can see this is a polynomial of 4th degree. So it's like saying x to the power 4 plus 8x cubed minus x squared plus 3x plus 2. So when we replace x with -2, -1, 0, and 1, we get the respective values in the P3 column over here. And for P4, it's basically a square polynomial. So yeah, this is an example of how we can create, we can do a polynomial creator and get our results accordingly. Now, interestingly enough, what we've done here is basically, like, for example, let's look at P3, right? P3 is basically this polynomial. Now, this polynomial function inside our decorator, polynomial creator. So all these examples that I've been showing you where functions are within functions, if you think of it, it's like I'm giving some basic function extra, like I'm doing something extra within them, right? So we can use decorators for this. And in our example over here, what I can do with this function is I can implement the same operation more efficiently by using a decorator within our main function. So we can factorize it in a way that it does not need any exponentiation. So we can, if you think of it, this polynomial can be represented like this, right? If you think of it, it's basically this times x plus some constant, and then that whole thing is again times x plus some constant. Since this is to the power 4, this is all we need. But if you think of it, if we keep going further, all you have to do is again enclose it in another bracket and then do times x. So we can basically use a decorator to do this function. So if you look at this function over here, what I've done is I've created the same polynomial creator with variable number of arguments. But inside this function, like what I've done in the form of a decorator is that I'm going to implement this polynomial by calculating the result in this manner, where it's going to be very much more efficient, and you don't have to keep exponentiating like how I did in this example. So that's what I'm doing over here. And if you see, that is basically implemented over here through this. So when I do the same, when I execute the same thing, and if I go through the for loop again, it should give me the same results, but it's much more efficient. Now let's look at another example of a simple decorator. So I've defined a function called our decorator func. Now this will basically be, this is a reference to another function itself, if you see within this. But inside my decorator, I have a function wrapper where I'm going to print this statement before actually calling the function x, before calling the function. And I'm going to perform a print statement again after that. And I'm going to return the function wrapper at the end of executing the decorator. So let's look at what happens when we define this function foo_x. So this is basically a simple print statement where I'm saying hi, foo has been called with whatever this is, argument. So now let's execute what happens when I say foo hi. So as you can see, let's execute the whole thing. So yeah, as you can see here, I have executed this. It says this is the print statement that I've basically written over here, and this is what gets printed when I call this function here. Now when I move on to the next statement, what I'm declaring is I'm going to now decorate foo with f. Now what this means is I've now created this this decorator object basically. So let's look at what happens when I execute this, and then I'll try to explain to you. So when I execute the whole thing, you can see something else is happening now. So we call foo after decoration, then we have this before calling foo, and this is basically this print function. This is the print function that gets executed here. Now we have this. This is the function call. This is basically the function call, which is basically this foo function. And this line is being printed from this. So if you see here, I'm getting some results from this, like from this decorator itself, but I'm also calling upon the function that is being referred to by this decorator. So I'm doing two things. I'm doing the main thing, which is being executed here, which is the result is here, but I'm also decorating it with these two lines, which comes from this decorator called our decorator. So let's look at the explanation. So if you look at the output of this previous program, we can see what's going on, and that is that the decoration foo, this when we did this line, which was over here, it's a reference to the function wrapper, which is this. Now in this function wrapper, this function itself, right, like this function that we defined here, that will be called as well, but we will also have a bunch of extra print statements in the form of these two lines, which you can see over here, before calling and after calling, that we've also done along with this. So this is a simple example of how we've used a decorator to modify our basic function. Now this usual syntax for decorators in Python is with the at symbol. So we can write the same thing like what we did before through this. So we write at our decorator, and this will basically apply the decorator to this function foo_x. So when we do at our decorator and then we define this function and we call it, it will basically do the same thing as doing this, for example. So if I execute this, you can see the same thing has happened here. Now I'm going to give you another example of a decorator. Remember the factorial function that we did earlier, where we did a check within the factorial function. Well, let's see how we can use decorators to aid our case in this. So as we know, before we calculate the factorial of something, we want to make sure that whatever we pass is greater than or equal to 0 and it's an integer, right? So let's define a decorator which will basically do this. So in this decorator, what we're going to do is we're going to create a function called helper, where we're going to perform this check, and this is going to be our decorator basically, right? However, so what this will do is basically this decorator will say, okay, if this check is met, then you can return the value of function of x, which is the function is what we pass in this as an argument to the decorator. So once the check is done, we can perform a factorial. So that's what we're going to do here. So we've defined our decorator. Now we're going to use the decorator here, and we're going to define within it a factorial function. So when we actually perform the factorial, like for some numbers, we're going to do factorial of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all these 10 digits from 1 to 9, sorry. So if you're going to do that, what it's going to do is at each step, so for the value 1, it's going to first check whether our integer passed is actually the correct form of an integer, whether it's in integer and greater than or equal to 0. So once that is done, then it will move on to the actual factorial function. So when we do for I in range 1 and 10, since every number is valid, we won't get nothing wrong will happen. there won't be any exception raised. But what if we did factorial -1 now? Now the factorial function itself doesn't have a check, but since we have a decorator around this factorial function, it's first going to do this check, and if it finds an error, it will raise an exception. So if I do this, if you see, when I execute, it raises my exception. So this is how we have added some functionality to the original factorial function using this decorator. In this video, we will be covering the topics of map, filter, and reduce functions in Python. Now, Python provides several functions that enable functional approach to programming. And since functional programming is all about expressions, some of these expression-oriented functions of Python are lambda functions, list comprehensions, map, filter, and reduce. Now, we've already covered the topic of lambda and list comprehensions. Now let's cover the topics of map, filter, and reduce. So to start off, let's look at the map function. The map function takes in two attributes, a function and a sequence. A function is basically some user-defined function or any function. A sequence is basically an iterable object like a list or a tuple, for example, or a bunch of lists and tuples as well. So let's look at an example. So one of the most common operations that we do with something like a list is doing an operation on each of the elements in the list and then outputting a new list with the values as whatever we have modified to the original items of the list. So what if we did the square of all of these items in this list, and we want to create a list based on that? So we can basically iterate through it, and we can do a square function and then append those values to a new list called squared. And when we do this, for example, over here, you can see when we print squared, we should get the list of whatever square values we have for the original list. But this is slightly a bit tedious. And what if we had a method what if we had a technique wherein we could basically pass a function that we want to do and a sequence on which we want to apply this, and we pass it to a function, and this function basically takes care of applying whatever operations we want to do on each element of a sequence. So this is where the map function comes in use. So let's look at how we use the map function over here. So if you look at this, I've defined a square function. So the square function basically returns, takes an argument x and returns the square of it. And I have a map function which takes the square function as one of the arguments, and the list or an iterable as the second argument. So this map function creates a map object, if you see here, as the list that I want to apply it on. Now let's list out all the items that are in this map object. So if you see, it creates me a list with basically the squared items, and this is exactly what we needed. And another way of doing the same thing would be just going through a for loop in each of the map objects and printing each, which would give me the same results. So if you see here, I found a very neat way of passing a function and an iterable and using the map function to apply each operation that is part of the function, or applying the function on each item in the iterable. So as you've seen, we basically passed in a user-defined function and we applied it to each item in the list. Then the map calls the square function on each list item and collects all the return values into a new list. And because map expects a function to be passed in, it also happens to be one of the places where lambda functions are appearing a lot. So let's look at an example where we do the same operation using a lambda function. So if you see here, I have a lambda function where I'm passing it as the function argument, and what this lambda function takes is some variable x or some argument x, it does its square and it returns that x. And this x is basically going to come from each element that is present in this list called items. And when we list down these, you will see it basically does the same thing for us. It creates a list with squared items. Now, we can also pass, instead of passing an iterable itself, we can actually pass a sequence of functions and use the lambda function to perform a sequence of functions on particular items. So let's look at a new example, a slightly different one. So we're going to use the numpy module for this. Don't worry, we're just using it to use the square root function that is present in the numpy module. We will be learning about numpy in a later section. So we're going to import this first. And now I'm going to define three functions called square, cube, and square root. So once I've defined these, basically they're returning the square, the cube root, the cube, and the square root of some integer x. And now I'm going to create a list of these functions that you've just seen. and we're going to use a for loop, and we're going to iterate through a range from 0 to 4. So, and we're going to pass this, and we're going to say that we want to apply some function. We want to apply some function x, and we want to return that using this lambda function. Now what values this x will take is based on whatever functions we've stored in this variable called funcs or funcs. And in funcs, we have a bunch of functions called square, cube, and square root that we have defined earlier. So what we're going to do is we're going to apply each of these functions to r, and r will take the values 0 to 4. And now let's see when we print this what values we get. So if you see here, we get a list of squares, cubes, and square roots for integers 0, 1, 2, 3, and 4. So this is another way of using the map function and lambda functions together to apply multiple different operations to a bunch of iterables. Now for our next example, what we're going to do is we're going to create a function that basically what it does is it creates the uppercase of some string that we pass to it, right? So that's what we've done here in this function called toUppercase. So let's first define this function. Now we have a print function basically which is going to print each object in a particular which is going to print each element of a particular object, and is going to at the end of it, and the end of printing, we're going to give a small space for printing a new line basically. So let's create this also, this print iterator object. Now what we're going to do is we're going to pass a string with the letters a, b, and c to this function, and we're going to we're going to apply the uppercase function to this string. Now if you remember, string is also an iterable where it's a sequence of one character strings. So this whole string is basically a sequence of one character string A, one character string B, and C. So we're going to, we can pass a string as an iterable to the map function because it will apply the operations on each of these characters. So let's see what happens when we do the uppercase function. We apply the uppercase function using the using mapping to this string A, B, and C. So if you see, it's created me a list with capital A, capital B, and capital C as we had expected, because we have applied the list function to the map object. Now, in the next step, what we're going to do is we're going to do a very similar thing. We're just going to, instead of simply mapping and creating a list out of it, we're going to store the map object in a variable called map iterator. We're going to print what type of object it is, and then we're going to print out each of the elements using the print iterator function that we defined here. So let's do this. Now if you see, the class, the type of object is of class map, and the objects elements inside the object are A, B, and C. Moving on, let's look at now an example where we're going to pass multiple arguments. So instead of one iterable, we're going to pass multiple iterables now, and we're going to apply some sort of an operation. So if you see here, what we have done is we've created two sequences. One is a list of some numbers, and another is a tuple of some numbers. So just to show you, let me first copy this here. So if you see here, I have a list and a tuple, and I'm passing both of these, if you see, to this map function. And before that, I have defined a lambda function as the operation that I'm going to apply. And what this does is it takes two arguments, x and y, and it returns the product of both of these. Where does it get x and y from? So the x it gets from this sequence, which is a list, and it takes y from this sequence, which is a tuple. So what it's going to do is going to take x as 1 and then y as 5 in the first step, and it's going to return the product as 5. And then the next step is going to take 2 as x and then y as 6, and it's going to return the product of that, and we're going to get 12, and so on. We're going to get 21 and then 32. These values are going to be stored in the map iterator, which is a map type object. And when we use the print iterator function, it's basically going to print out whatever results we got through this mapping. So let's execute this, and as you can see, this is the result we got: 5, 12, 21, and 32, which is what we wanted. So the next part, the next function that we're going to discuss is the filter function now. Now a filter function is basically, again, it takes two arguments, a function and a sequence, and a function basically tests if each element of a sequence is true or not. Now a sequence, so this filter function will basically take two arguments. So one is the function, and this function is basically going to test if each element of a sequence is true or not, and it's going to take another argument called sequence, and this argument sequence is the list or the tuple or basically any sequence or iterable that needs to be filtered. And it can be, as I mentioned, it can be sets, lists, tuples, or containers of more iterators. And what this function will return is an iterator that is already filtered. So let's look at an example now. So we have this list R which we've generated, which is basically numbers from -5 to 4. So if I create this list here, you can see it will create a list of -5 to 4. Now, if I wanted to extract only the values that are lesser than 0, well, I can use a for loop and use a if condition to check this, right? So if I did this over here, you can see it returns me some list called result, which contains only the values lesser than 0, which is basically checked through this condition. What if there was a neat or a more convenient or a more organized approach to doing the same thing? Instead of creating a loop ourselves, what if we defined a function where we are going to do the test, or we're going to create the condition, and we're going to pass this to a particular function and then apply that particular operation on every object of some sequence? Well, just like mapping, we have a filter function to do this. And in this example, what we're going to use is the lambda function, which takes an argument x and it checks for some condition x lesser than 0. And where it's going to get the x from is some sequence R, which in our case is the numbers from -5 to 4. And the filter will basically create a filter object type, which contains only the objects from R, this condition, that is x is lesser than 0. And when we use the list operation on top of it, you will see it results in a list with the values that have met my condition. So for a second example, what we're going to do is we're going to create a list which contains a bunch of letters, and we're going to only extract the vowels from these bunch of letters. So let's look at what we have here. We have some letters D, A, T, J, K, O, P, L, and we only want the vowels from this. So we want to filter only the vowels. So we can use that using the filter function by first of all defining a function that returns true if a check is met that one of the letter matches one of these letters in this list called letters. And if it doesn't, it returns false. So this is our condition that we've created. Once we create this condition, this function that checks this, we can pass this function and the sequence into the filter function, and then we can list out whatever we get. So you can see our filtered list contains only A and O, which is basically the only vowels that are present in our original list. Finally, we have the reduce function. This reduce function is basically a functools. It's in the functools module of Python 3.0. And what the reduce function does is it applies a function of 2 arguments cumulatively to the elements of an iterable, and it optionally starts with an initial argument, and it returns a single result. So let's first import this function. And once we've imported it, let's use it in this example that we have here. So in this example, what we're going to do is we have some list called numbers, right? What if we wanted to get the sum of each element in this list? Well, we can iterate over it and store it in some variable called total in each step, right? This is what we would typically do. And in this step, what you can see is the loop basically iterates over every variable in numbers and accumulates them in total. The final result is the sum of all the values, which is the value of 10 over here. In this example, the variable total is what we call an accumulator, and we can apply the reduce function to do the same task. So how do we do it? Let's first of all create a function called myAdd, where we're going to take two variables, 2 arguments, and we're going to return the sum of it. Okay, so let's define this function, and now we have our list called numbers, right, which contains 1, 2, 3, and 4. Now let's do reduce myAdd to numbers. Now when I use this function, what it will do is it will apply the function of myAdd. It will take basically each and every element in a sequence. So it will take 1 and 2, then add them together, and then it will create, basically what it will do is it will take 1 and 2, add them together, then we'll have 3. So it will take 3 and then the next element, which is 3 again. So it will create the sum, which is 6, and then it will take 6 and then it will take the value 4 and it will give us the result 10. So this is how the reduce function would work. So this is how it will give us the result of 10. As you can see here, I've passed this function where I've defined that I want 2 arguments to be passed to a function, and then the return should be basically the sum. And then I've passed a whole list of like 4 numbers, and I've used the reduce function to basically do this process for 4 numbers in a step-by-step manner by taking 2 at a time subsequently. And my result, as you can see, is correct, as you can see here. So let's use the lambda function now to do the same task. So what I'm doing now is I'm going to define a lambda function, and that's the function I'm going to pass to this reduce. So when I pass this lambda function, which basically takes two arguments, x and y, and it's going to return the sum of that as x plus y, Now where it's going to get x and y from is in a very neat manner. So it will take first the first two elements, 1 and 2. It will then do the sum and we get 3. Then it will take that same 3 and then take the next object, which is 3 again, and then give us 6. Then it will take 6 and then the next element, which is 4, and then give us 10. And then the reduce function will output the single result, which is 10 to us, as you can see here. So yeah, this was our video, a discussion on map, filter and reduce functions in Python. I hope it's a valuable addition to what you already know about lambda and list comprehensions. In this video, what we will be covering is certain abstract data structure concepts, and we're going to implement these abstract data structures using basic Python techniques, and also we're going to get slight introduction into object-oriented programming to perform these or to create these abstract data structures. So you can consider this as an exercise or an activity in OOP plus some basic Python concepts. So let's talk about what stack is. Stack being the abstract data structure that we are talking about over here. So the name stack resembles a pile of objects, right? It can be a stack of papers, a tower of blocks, where adding and removing of an item occurs only at the top of the pile. So a stack is an abstract linear data type, which is a collection of objects that supports fast, last in, and first out semantics for inserts and deletes. Unlike lists or arrays, stacks typically don't allow for random access to the objects they contain. So you can't just access something by an index in a stack. You either go from the top or the bottom of the stack. So what we are going to use is insert and delete operations, which are often called push and pop respectively. Stacks and queues are both linear collections of items, but however in a queue, the least recently added item is removed first. So it follows a first in, first out approach. On the other hand, in a stack, the most recently added item is removed in the beginning. So it's like last in and first out approach. So a real life example of a stack is a pile of heavy and precious plates, all kept on top of each other. So if you wish to remove a plate, if you wish to add a plate or remove one, you can only do that from the top. And if you want to remove a plate from the lower bottom of the stack of plates, you have to remove from the top one by one, in a practical example, of course. Used for real world analogy for a stack data structures, of course, stack of plates. It can be a pile of clothes as well, where you typically want to remove or put everything from on top of the pile and not in the middle or the bottom of the pile. So yeah, so this is a visual representation of a stack where this whole it's a linear collection, but whatever we do is usually something to do with the topmost item or the last entered item of the stack. Now basic operations that can be performed in a stack are mentioned as follows. So there's a push operation, which basically adds an item to the stack. If the stack is full, it is called it is said to be in an overflow condition. There's a pop operation, which removes an item from the stack. It follows a reversed order to pop items, similar to the way when items are pushed. So in that case, we call it an underflow condition. Now there's peek or top operation, which basically returns the top element of a stack, and then there's the is empty operation, which returns true if the stack is empty and false if it is not. Now the applications of stacks, like where do we use them? They can be used to reverse a string. It can be used in expression evaluation, expression conversion. It is used for forward and backward features in web browsers. It is used in recursive passing in NLP, and so many other operations are there and applications for stacks. Now let's understand stack operations. So the two most basic operations are, of course, push and pop. Now when we want to push, what we're basically doing, let's consider an example. So let's consider editing a Python file using the undo feature in our editor. So we have a clear understanding of the stack operations. So at first, say a new function called insert is added. The push operation adds the insert function into the stack. So this is a visual representation of what we're talking about. So we have this empty list, this empty stack initially, and what we're going to push onto this is the insert. Some function, say let's call it insert, or some object called insert. So once we've done this stack looks like this. It has an object called insert, right? Now a word delete is removed. Let's look at the next thing now. Let's say I push something called delete now onto this, right? So if I push delete, some object called delete onto this, it goes on top of the insert stack, right? Because this is a stack. Everything occurs in a top, like the last thing that you have added is the first thing that you will see from the top. So we see delete first. In terms of our example of our Python script, assume the script as the whole stack. where we initially had a function called insert and then we added a function called delete. And now in the same script, we want some comments for each of these functions. So think of it as another object that we're going to add on top of all of this, right? So now we have this Python script where we have the first function called insert, the second function called delete, and a bunch of comments pertaining to these. And that's the last, basically, that's the last object that we added to our Python script. Now let's perform some pop operations. So the first, like say we did undo. Now we have a Python script with all of these things. Now let's say we pressed undo for something. Like say we press undo. Well, what is the first thing that is going to go? Of course, it's the last thing that we entered, right? And the last thing we entered was a comment. So when we press undo, what gets popped is the topmost thing, which is the comment. And the comment is now gone. And what we have left in the script is the other two things. And if we hit undo again, well, the next thing that would be removed is the next most recent thing that was added, which was the delete function. And then if we hit undo again, the insert function will get removed. So this is how the pop function and the push function works in terms of stack, where I gave you the example of the undo operation in a Python script. Now let's implement a stack in Python. There are some basic implementations, and they are as follows. We can use lists, we can use collections.dequeue. I'll show you what that is. And we can use the custom method, which is basically the OOP example that we were talking about. And there are numerous third-party packages which we may or may not look into. But for the sake of this particular video, we're going to be looking at these first three cases in particular. So let's look at the first option, which is a list built-in. Now the Python's list object type already has a decent stack data structure approach, as it supports push and pop operations by default. So let's create a list called S. Now what I'm going to do is I'm going to append this list with a bunch of strings. So first I'm going to append it with eat, sleep, and then code. So if you see here, if I print my list that I'm going to treat as a stack, these are my objects, right? Now if I had to pop from this list, your question would be, well, what is the first object that comes out of this list? Well, since we're going to treat this as a stack, and since pop is a stack operation, it will pop out, or it will remove the last most added, the most recent added object, which was the string code, right? So if I had to execute these, you will see when I do the first pop, the object that gets popped out is the last thing that was added, which is code. Now if I did pop again, it will remove sleep, because that was again the next most recent one. And finally, if I did pop again, it will remove eat. It's important to note, oops, 1 second. So if I do this, then if I did pop, and then, okay, so what happened here was basically the pop. Okay, so I'll tell you what. So let's look at an example where I'm going to be using this. So let's define my stack as some list S, and I'm going to append eat, sleep, and code to it. So the first object that gets appended is obviously eat, then sleep, and then code. So if I were to pop these objects, the first object that should come out is code, followed by sleep, followed by eat. So let's look at what happens when I actually try doing it. So let's print out what's in S. So if you see, this is basically my list S. Now my first pop should remove code, as you can see. My next pop should remove sleep, as you can see. Finally, it should remove eat. Now the question is, what if I did pop again? Well, an underflow error would occur. So if I did pop again, you see this error, and it says you cannot pop from an empty list, because I have popped every item, which were 3 items, and the fourth pop well, there's nothing else to remove from the list. So it gives me an error. Our next option for stack implementation is using the list, using the collections.dequeue. So this is a basic, it contains, basically Python has a module called collections. It comprises of the dequeue class, which is a double-ended queue that supports inserting and removing elements from either ends of an object. So since dequeues support adding and removing from either side, they can serve both as queues and as stacks as well. So let's import this dequeue class, and I'm going to create an object called queue of class dequeue. And what I'm going to do is I'm going to do the same thing. I'm going to append eat, sleep, and code, as you can see here. Let's check what's in queue. Well, it's a dequeue object of it's an object of class dequeue with the objects eat, sleep, and code. So again, if I did the pop operations, it should remove code, sleep, and eat in that order, because that's the reverse order in which I have added them in, right? So let's look at it. Code gets popped first, then sleep, and then eat. And of course, if I try to pop even further, it should throw me an error, because It's an empty D queue now. There's no objects left in it. Now the third object is using custom. It's using custom method, using classes and objects. So this is basically our example of how we're going to create a class and use basic concepts of object-oriented programming to create our stack. So let's start working on this. So the following stack implementation assumes that the end of the list will hold the top element of the stack. As the stack grows, basically as the push operations occur, new items will be added on top of the list. Pop operations will manipulate that same end. So let's create our stack. We are going to create a stack class called stack top n. It will have an initializer which will basically initialize a list called items. Now once we've done that, we're going to so this is basically the str function. Don't worry about this. Let's look at these functions which we are concerned about in this particular example. So we have a after we defined our str function, which is basically what it's going to do is going to print the contents of the stack that we have when we invoke the print function for a particular class object. Now the custom functions, the custom methods that we have created are isEmpty, push, pop, peek, size, and display all items. They're very similar to the predefined push, pop, peek functions, etc. So what these will do is the first function isEmpty is, as the name suggests, it's going to check whether the list called items is it empty or not. If it is, it will return true, otherwise it will return false based on this check. The push function, it's going to append an item, whatever we pass to the list items. The pop function on the other hand is going to do the pop operation as we have already seen. The peek function, what it's going to do is, if you see here, it's going to give us the item in the lastmost index. So if a length of a list is 10, then its last index is 9, since Python is zero-based indexing, right? And if we want that last index, we can just do length of that particular list minus 1, and then we can use that as an index for our list. So this is basically what's happening here. We're going to check for the last item in the list called items. So yeah, penultimately we have another method called size. What this will do is basically return the length of our object of our list of items. Finally, we have the method called display all items, which is going to return the list itself. So let's initialize a stack. We call it S. As you can see here, let's execute this first. Now we initialize this. We call it S. Now we print S. What it does is, well, it doesn't do anything, because what the print of function should do is it should return us the stack contents, which is nothing right now, because we haven't added anything to our list. So we check if it's empty, and we see, yeah, it is true, it is actually empty. So let's start pushing items into this list. So the first one that we push into it will be a string called first, then we push second, and then we push third. So let's do this. Once we have done this, now if we print this object S, it should give us the stack objects or the stack contents, which is, if you see here, what I've done is I've actually pushed first, second, and third twice by mistake. So it basically contains a list of first, second, third, followed by first, second, third again. Again, this is not an issue. We can work with this as well. Now let's look at the most recent item inserted. So since I have entered first, second, third, followed by first, second, third again, so this list is basically a list containing these objects, right? Like first, second, third, followed by first, second, third. And if I were to peek, now what was the peek function? The peek function looks into the lastmost object. So the peek function should look at the object that I added most recently, which was the string called third. So if I print this, it should give me third, which it does over here. Now if I wanted to view the stack, it's a simple, I can iterate through all of this and print each item. As you can see, since I have added it twice by mistake, what it's going to do is it's going to give me everything, as you can see here. So it basically, what this means is my stack contains the objects first, second, third, first, second, third. Similarly, I can also use the display all items to do the same thing, to show the same thing, as you can see here. Now I can add a boolean. So what this push will do is it will add a boolean object called true. So if I push this to it, now this stack contains a boolean object called true as the last object. So let's see. So if I wanted to see what S contains now, what I can do is I can do display all items and check. Let's see what is there now. So if you see, I have my objects here, but now since I added a true object, you can see that over here as well, a boolean object called true. Now let's print size of stack. So we use the size function. It should be 7, as you can see here. Now let's push another object. So this object is a float object called 8.4. And once I pushed it, and if I want to display everything, as you can see, now I have finally another object called 8.4 in this. So if I were to pop now, what will it pop? It will pop the recent most added, which was the float called 8.4. And if I did that, as you can see, I should get 8.4 here. Finally, if I were to display whatever is left here, it should display everything except the 8.4, which I have popped earlier on, as you can see. So in this other implementation, what I'm going to treat the top as is the beginning of the list. So the 0th element is going to be my new top now for the stack. So let's look at how things change because of this. So again, I have initialized a list, an empty list, and I'm going to have something, an isEmpty function to check if the list is empty. I have a push, which will basically now not insert objects from the last. It will not append objects anymore, but instead what I'm going to do is I'm going to insert objects to the 0th index of the list item. And when I do pop, it won't remove the item in the last index, but it will remove the item at the 0th index. Similarly, peek function will also do the same thing. It will look at the list from the left hand side. So it'll look at the 0th index object. So that's the peek, and then the size is the same thing. It's going to return the length of the list, and display all items will do the same thing once again. So now I have, once I've created this, let's create an implementation called stop 0. Now is stop 0 initially empty? It should be true. Let's push first, second, and third now. Once I push these, let's look at what was the most recent item that was inserted, which should be third, right? Let's view this stack. Like, how does it look? So if you see here, if I print them one by one, it prints third, second, and first. So even though I've added first, second, and third in this order, the items in which I retrieve it is third, second, and first. And that is because of how I defined this stack, where the top of the stack is actually the 0th index. So if I did display all items, it should give me a list with third, second, and first in that order. So if I execute this, you can see this over here. So again, if I did just to see again, my peek will basically give me third. Now using these concepts that we have learned, let's perform an exercise. This exercise is going to be where we are going to write a function where we're going to reverse the characters in a string. So let's look at how we are going to implement this. So if you remember this class, stack top n, from this earlier case over here, we're going to use this class to create an instance of that class. So what we're going to do is we're going to call it myStack. And our input string that we're going to use is called Bangalore. We're going to reverse the characters of Bangalore. So what we're going to do is, first of all, we're going to push each string, each character of the string into the stack object using the push function. And then let's see what our object looks like. So as you can see, we have pushed each character of Bangalore into a list, and we've stored it right now for now. So let's initialize an empty list and an empty string. Now what we're going to do out here is basically the reversing operation. So as long as my initial list, which is called myStack, this object, as long as this object is not empty, what we're going to do is the pop operation. And we're going to keep adding, we're going to append each item that we get from the pop operation and add it to our empty string. So we're basically going to create a new string with letters that we pop from this particular list, which is basically what it's going to do is it's going to pop E, then R, and then O, and we're going to add it one by one in that order and create a new list, a new string out of it. So this is how we're going to do a reversing string operation. So once we execute this, and we're going to print what is the reverse string is. So if you see here, the reverse string in the form of a list is like this, and if the string form of the reverse string is, as you can see here, which is basically Bangalore reversed. As always, I thank you for watching this video. I hope you learned something about the stack, the abstract data structure in Python, and how we implemented it using basic Python lists, dequeues, and an object-oriented approach to the same. As always, like, subscribe, and share this video with your friends so we can reach out to new learners. I hope to see you in the next video, and thank you for watching.
And that brings us to the end of this video tutorial on Advanced Python Programming course by SimpliCode. I hope it was useful and interesting. Thank you for watching.